So dito tayo ngayon sa seismic definitions. First, identify natin yung zone from figure 208-1 and table 208-3. So from this figure, kapag yung location mo nandito sa zone 4, then it is zone 4. So this is Luzon, Visayas, Mindanao, and then this is a part of Palawan. Okay? Kung yung building mo nandito, then you use zone 2. For the importance factor I sub W, let's look at table 208-1 and table 103-1. Ito siya. So, ang building natin is commercial, residential. So, tingnan muna natin yung occupancy category. Okay? So, ito tayo. So, under essential facilities, this includes occupancies having surgery and emergency treatment areas, and then aviation controls, and then hospitals. So, hindi kasama dito yung ating building. And then hazardous facilities, obviously not. Wala naman tayong storage ng mga chemicals. And then special occupancy, building with an assembly room with occupant capacity of 1,000 or more. And then college or educational with capacity of 500. Hindi pa rin dyan pasok. So, malamang dito tayo sa 4, which is standard occupancy structures. This is all structures housing occupancies or having functions not listed in categories 1, 2, or 3, and category 5. And then 5, this is miscellaneous structures such as private garages, carports, sheds, and fences over 1.5 meters height. So, dito tayo sa standard occupancy number 4. Ngayon, punta na tayo sa table 208-1. So, seismic importance factor. Okay, so, under standard occupancy category or standard occupancy structures, number 4 tayo. Ang importance factor I is 1. Okay? So, seismic importance factor I is 1. Ito. So, highlight ko muna yan. That means natapos na natin siya. And then, dito tayo sa RWX and RWZ. Okay, so table 208-11A. Take note na ang ating seismic source type is A, taken from table 208-4. So, punta muna tayo sa table 208-4. Ito siya, no? So, ang gagamitin natin is type A, meaning yung magnitude na design natin is ranges from 7 to 8.4. Okay? Ibig sabihin, yung building natin, kaya niyang masustain ang ganitong intensity. And the seismic source description, these are faults that are capable of producing large magnitude events and that have high rate of seismic activity. Okay, so laging A ang gagamitin natin. So now let's go to T208-11A. And this is the earthquake force resisting structural systems for concrete at meron din pang steel. So for now, dito muna tayo sa concrete. So ang ating frame ay moment resisting space frame. Okay, so ito yung MRFS na tinatawag. So ito ay composed of simply beams and columns at walang brace. So ang R mo is 8.5. Tapos, sa zone 2, okay, this is NL. NL means no limit. Sa zone 4, ibig sabihin yan, no limit din. Ngayon, kung ang building mo ay may bearing wall systems like this one, special reinforced concrete shear walls, ang R mo is 4.5. Tapos, this is limited to 50 stories only sa zone 4. Kung ang building mo naman ay intermediate precast shear walls or braced frames, hanggang 10 story ka lang sa zone 4. So, things like those. So, kadalasan ang ginagamit ko is 8.5. Dito lang, kasi beams and columns lang. Pero kapag matataas ng ang structures mo, that's the time na i-consider mo na nagagamit ka ng shear walls kung concrete, o kaya gagamit ka ng bracing, diagonal bracing kapag steel. So, meron ding sariling table ang steel. In some cases, pwede kang gumamit ng dalawang R value. So, kasi meron kang X direction tsaka Z direction. Kung sa X direction mo, panay beams and columns lang, then gagamit ka ng 8.5. Pero kung sa Z direction, nakita mong malakas ang seismic forces doon, then gagamit ka ng shear wall, mag-iiba ang value mo sa Z direction. Okay? Pwede kang maging 5. Yan. And as much as possible, i-maintain mo na ang structure mo dapat, kung may shear wall sa Z direction, dapat may shear wall din siya sa X direction. Okay? Kung wala, then in both directions, dapat wala. Ayan, no? So, see, meron siyang X tsaka Z. So, natapos na tayo dito sa 8.5. Dito na tayo ngayon sa soil type. So, SD ang kadalasan na ginagamit. Sa table 208-2 tayo ngayon. Ito yun. Table 208-2. So, soil profile types. Kapag A, ibig sabihin nun, hard rock. Kapag B, rock, and then C, very dense soil and soft rock, and then D, steep soil profile type. And then, makikita mo dito yung SPT value. SPT stands for Standard Penetration Test. So, ito yung kailangan natin, yung N value. So, this is the number of blows per 300 mm. If your N is greater than 50, then gagamit ka ng S sub C. If your N value is from 15 to 50, then gagamit ka ng S sub D. Itong kailangan natin, yung soil profile, ay yung standard penetration test N value. Now let me show you an example of this. So ito ay this is a geotechnical investigation report, ano? Dito yan sa Solano. By the way, this is for a 5-story Church of God World Missions Philippines building. Okay? Pakita natin yung contents ng SPT. Ito. So, ayan yun. And then, ang depth of excavation, that is from the top. Okay? That is 0 from this level. Take note na ang design, ang depth of excavation ko nasa 3.7 meters. Okay? And 3.7 meters is nasa 12 feet. Okay? So, sa 12 feet. Balik tayo dito. And, ang depth ay somewhere here. Okay? Somewhere here. Ngayon, tingnan natin kung ilan ang number of blows. So, let's say, gamit tayo ng line. So, papatak siya from this is 0, 10, 20, 30, 40. So, midway between 10 and 20, yan yung range nung 12.5. So, pasok siya sa 15. Sabihin mo na. Okay? And, yung 15 is nasa S sub D. Yan yun. Okay? So, gagamit tayo ng stiff soil profile. Yan ang ilalagay natin dito. Okay? Ngayon, makakakuha ka ng or i-require ng building official ang geotechnical report kapag 3 stories ang structure mo pataas. Ngayon, kung less than 3 stories, let's say 2 story lang, magtatanong ka na sa building official kung ano ang soil profile type, or pagtanong-tanong ka sa mga kapitbahay na construction. So, tapos na tayo dyan. Now, let's go to NA and D. So, tawag dito ay near source factors. Now, let's go to table 208-5 and figure 208-2D. So, ito. Table 208-5 and table 208-6. So, ang distance na ginamit ko is 12 kilometers from the known seismic source. Let's say, ito yung seismic source, yung red line. Then, this is the location of the project. So, that is 12 kilometers. Malalaman mo tong distance niyan. In the old days, gumagamit kami ng scale. Tapos, susukatin namin yung nasa NSCP book. Pero ngayon, meron ng app sa cellphone na gawa ng PHIVOLT. Ang tawag dun ay Fault Finder. So, i-download nyo yun. Tapos, make sure na naka-on yung GPS ng inyong cellphone. And then, pumunta ka sa site. I-click mo yung app na yun. Sasabihin niya kung ilang kilometers yung distance from the nearest fault line. Okay? Dito sa Solano, ang distance to the nearest fault line is about 4 kilometers. Meron fault line dito sa Madyangat. Okay? Dati-rati ang nearest fault line dito sa Solano yung nasa Digdig, somewhere in Nueva Ecija. Okay, next. By ratio and proportion, kapag 2, let's say 2 ang distance mo, pakita ko lang, ano? Ang NA natin would be 1.5. Take note na dito tayo sa seismic source type A. Okay, always A ang gagamitin natin. So, if 2, then your NA is 1.5, tapos ang NB mo ay 2. Now, let's put in 5. By the way, ito, ginawa ko lang ito using ratio and proportion. Kapag ang distance is 5, then NA is 1.2, tapos NB is 1.6. Now, let's type in 10. So, 1, tapos 1.2, then type ko 15. Note that 15 is greater than 10, kaya 1 pa rin itong NA. Pero dito, yung NV, naging 1 na siya, okay? So, balik ko sa 10. Yan. So, nag-adjust. Ayun, pasok natin yung 12. So, 12 is between 5 and 10. So, that is 1.6 something. Okay? I mean, 12 is greater than 10, kaya ang NA natin is obviously 1. Ngayon, ang 12 is between 10 and 15. So, lumalabas na 1.12. So, this is by ratio and proportion. Ito ang ipapasok natin, 1 and 1.12. Next is yung ating CT value. Punta tayo ngayon sa 208.5.2.2. Ito, so 208.5.2.2, this is the structure period. CT is 0.0731 for RC moment resisting frames and eccentrically braced frames. Ang ibig sabihin nung eccentrically braced frames, ito yung may mga diagonal bracing. And then, kapag steel naman, 0.0853. Okay? Ganyan lang kasimple. Kapag steel, ayan ang gamitin mo. Kapag concrete, 0.0731. And then, if it does not fall between these two, then you use 0.0488 for all other buildings. Okay. So, gamit tayo ng 0.0731. So, this is taken from your NSCP. Ngayon, ipapasok na natin siya sa STAAD. So, i-close ko na ito. By the way, pakita ko lang yung contents ng geotechnical report. Ang importante dito, okay, yung nasa first 3 pages. Ito. So, this is page 2. Yan. Nasa page 2, dyan mo makikita yung bearing capacity. Dalawang bearing capacity dito. Yung allowable soil bearing pressure, this is without seismic, tsaka yung considering seismic loads. So, itong kailangan natin considering seismic loads. So, yan, 187 kPa. So, this is in Solano. Dito sa Solano, nagre-range yan ng 180 up to 199. Okay, so meron na akong building dito sa malapit sa sentro, umabot siya ng 190 something. Papunta sa towards Bayombong sa area ng 24/7, I think that is 180 something, and then katabi ng 24/7 tumataas siya ng konti. Ito yun, 187. So yan ang kailangan natin. Next is the foundation support, okay, which is on page 3. It should not be less than 2.5 meters below the existing level where the geotechnical investigation drillings were conducted. Okay, dito tayo kung minsan nagkakaroon ng question. So, below the existing level, maraming klaseng level. Merong NGL, natural grade line, merong level na natambakan, tapos nilagyan ng flooring, things like those. Ngayon, ang ibig sabihin tong geotechnical investigations were conducted, dito nag-umpisang magbutas. Okay? Ngayon, in one of my projects, yung from the rice field, meron siyang tambak na 1.7 meters. Okay? Ngayon, yung kalsada, nasa range siya ng 1.5 meters from the rice field. Okay? Tapos, yung pundasyon, syempre, kailangan mas malalim sa level ng rice field. Ngayon, kung kukumputin mo to, 2.5 meters below the existing level. So, ibig sabihin, 2.5 minus 1.7 nasa 0.8 meters na lang. 0.8 meters ang huhukayin mo mula sa rice field pababa. Siyempre, magtataka ngayon yung naghuhukay, yung contractor. Engineer, bakit 0.8 meters lang ang huhukayin mo from the rice field? Ang building mo, 3-story, 5-story. Yun ang question natin ngayon. So, that's the time na pwede mong tawagan yung gumagawa ng geotechnical report, pwede niyang i-increase ito. Or, pwede mo pa rin gawing 2 meters from NGL. Okay? Or 2 meters from the rice field. So, 2 meters plus 1.7, that would give you 3.7 meters below the existing level. Anyway, 3.7 is still greater than 2.5. Ibig sabihin, hindi ka pwedeng bumaba ng less than 2.5. Bawal yun. Okay? Tapos, itong settlement parameters, kailangan mo itong unit weight, 16.5, tsaka itong 0.002. Ito yung angular distortion. Gagamit mo ito kapag gagamit ka ng spring constant kapag mat foundations na. Okay, so aside from that, kailangan natin yung SPT count nya, yung N value. Ito. Okay, para malaman natin kung anong type of soil. So, punta tayo ngayon balik tayo sa STAAD. Sa loading, punta tayo dito sa definitions. Tapos, sa seismic definitions. And then, you click add. Dito tayo sa type. We choose UBC 1997. And then, dito sa zone, type mo dyan ay 0.4. Tapos, importance factor I is 1. And then, RW, 8.5. Tapos, soil profile type is 4. Okay? Yan. Dahil ang 4, nasa SD siya. Tapos, ang ating NA is 1. NB is 1.12. And then, our CT value is 0.0731. Blanco mo lang yung dalawa kasi si STAAD nang magko-compute niyan. And do not check this one. It says here, do not check accidental load because rigid dry diaphragm was considered. Check this item only if master slave is used. Okay, so in the old days kasi, way back before this Connect edition, chine-check namin ito kasi hindi pa siya nag-auto-compute ng diaphragms. Hinahanap pa rin niya yung master slave, master node. Okay? So, let us close this. And, you click add, then close. Okay, so ito na yung naidagdag. And then, punta na tayo ngayon sa load cases details. Dito yun, under loading. Punta tayo dito sa load cases details and then add. Ang ating number 1 is loading type seismic, and then EX, okay, caps lock EX, and then add, tapos 2 EJ. Lagi mong uunahin yung seismic loads, 1 and 2 seismic loads, okay, dahil malilito si STAAD kapag inilipat mo si seismic loads ahead of dead or live. And then number 3, that is our dead, then that is DL. In some cases, ang dead, dalawa yan, ano? DL roof, tsaka DL. Yung merong dead load para sa roof, tapos meron ding dead load for the superimposed, and then meron ding dead load due to self-weight only. Okay? But for this structure, isa lang ang ating dead. Halo-halo na dyan. Nakasali na dyan yung self-weight, yung superimposed dead loads. Okay? So, we now click number 4. This is live. So, change this to live. And then, change this to LL. Then, add. Then, close. So, let's check. EX, EZ, number 3, DL, number 4, live load. No. Do not click reducible. Okay? Sa live load. Kasi, kung minsan, yung live load mo, kapag greater than 4.8, pwede mong i-reduce yun ng 50% or 0.5. Now, let's do this. At zone 0.4, IRWX, things like those, add or new reference load R1 factor 1. So, gagawin natin ito. Okay? Balik tayo sa STAAD. So, dito tayo. Ayan. Tapos, i-click natin si add. Okay? Yan. Diyan. Click mo yan. Then, click add. Tapos, ang reference load natin, ayan. And then, i-click mo lang ito. Dalhin mo dito. So, i-click arrow right. And then, ang factor niya is 1. Make sure na this is along Y. Okay? Hindi siya pwede sa X, hindi siya pwede sa Z. Okay, so that is along Y. And then you click add, then close. Next is ang ibig sabihin nito, sa dead load, ipinasok dito sa seismic definitions, magko-compute siya ng base shear using gravity loads. That includes self-weight and superimposed dead loads. Pero, kinompute na natin yung dead loads dito sa reference load definitions, which is yung R1. Kaya, ipinasok natin si R1 dito kay seismic. Okay? So, ibig sabihin, hindi na tayo mag-uulit pa ng katakot-takot na sangkatutak na loads dito. Okay? So, under load cases details, dito ngayon, i-click natin si EX, tapos i-click add. By the way, I'm just following this pattern, no? Dito kay EX, you click add. and then you click seismic loads, tapos ang direction is X, factor is 1, and then you check multiplying factor for accidental torsion moment, okay, with a factor of 0.05. So ito yung tinatawag na 5% accidental load. And then next is check multiplying factor for natural torsion moment, and the factor is 1. After that, you simply click add. Okay, so meron na tayong seismic sa X direction. Now let's close this. Ayan. We do the same for E sub Z, or in the Z direction. By the way, yung accidental torsion moment na 0.05, or that is 5%. Ang purpose niyan, kapag yung building mo is highly symmetrical, ang movement niyan back and forth lang. Kailangan hindi lang back and forth, dapat meron din siyang twisting. Kaya gumagawa siya ng eccentricity na 5%. That means yung center of mass iminumove ni stud ng 5% sa X direction, tsaka 5% din sa Z direction. So, magkakaroon ngayon ng twisting or torsion effect sa overall building. Okay, so that is written in the code. Now, let's do E sub Z. So, from here, you do the same procedure, add, tapos seismic, and then this time the direction is Z, factor is 1, multiplying factor for accidental is 0.05. Ito na yung ginagawa natin ngayon. Tapos multiplying factor for natural torsion is 1, and then you click add again, then close. Tapos i-click natin itong si dead load. And then from there you click add. Tapos i-click natin si reference load. Nasaan siya rito? Ito, nandito siya kay repeat load, ano? Ayun. So, i-click mo si reference load, then you select this, you click arrow right, and then the factor is 1, and then you click add, then close. Okay, next is pwede na tayong maglalagay na tayo ngayon ng check soft story. So at editor, type check soft story as 7 after the last line of floor diaphragm. So ito, punta tayo ngayon sa utilities, and then sa command file, just click save, scroll down, hanapin mo si diaphragm. Ayan, so floor diaphragm, and then after the last line, you just press enter here, and then you type there check soft story ASE 7. Okay, so ayan, check soft story ASE 7. Then click save. Gagawa na tayo ngayon ng live loads naman. So, dito sa load cases details, you select LL and then you click add. Okay? So, LL, then click add. And then, punta tayo sa repeat load. Okay, tapos punta tayo sa dito pala tayo sa floor load. Yan. Okay, so ulitin ko. Cancel ko lang yan. Click LL and then add. Then you click floor load. Tapos you click group. And then dito sa pressure, negative 2.4. Okay, saan natin kinuha yung 2.4? Ang ating loading ay office. So, pag offices, that is 2.4. Kapag residential, 1.9. And then, global Y, i-assign natin yan dito sa this slab. Then, you click add. Tapos, i-assign din natin yan dito sa 2F, two-way. This is actually your hallway. Notice na 2.4 din ang gagamitin natin. Pero, kapag i-design mo yung slab as independent member, 4.8 ang gagamitin natin. Okay? Ayan. Use 2.4 for frame loading but use 4.8 for design of corridor or hallway slab. Next, you click add. Tapos, ganon din dito sa third floor. Negative 2.4 pa rin, ano? And then, dito sa third floor, negative 2.4 pa rin. Lahat yan, negative 2.4. Then, close. So, you have now 1, 2, 3, 4, 5 floor loads. After that, punta na tayo ng stair loads. Sa stair loads, negative 4.8 ang gagamitin natin. Okay? Ang ibig sabihin niyang 4.8, that is access floor system or exit facilities. So, 2.4 kPa for frame loading but use 4.8 kPa for design of stairs. Now, bakit naging negative 4.8 yan? Take note na ang horizontal projection of length is 2 meters. Saan nanggaling yung 2 meters na yan? Punta tayo ngayon sa horizontal projection of this actually stair length. Okay? Ayun. Horizontal projection of stair length. Or this is horizontal length of stair divided by 2. Okay? So, check natin. Punta tayo sa ating figure. Sa geometry. Ayan. Remember na ang stair horizontal length natin is 4 meters. So, kalahati ng 4 meters is 2. So, dyan natin kinuha yung 2. Okay. Next, yung negative 4.8 na yan, minultiply natin si exit facilities na 2.4 times the horizontal length projection. Kaya siya naging 4.8 negative. Okay? So, it does not necessarily mean na 4.8 dahil yan ang nasa code. E paano kung yung horizontal length of stair mo is, let's say, 3.5 meters. So, that is 3.5 divided by 2. Okay? So, magiging 4.2 na lang siya. What if 6 meters yung horizontal projection mo? So, that is 6 divided by 2 will give you 7.2. Okay? So, simply said, 2.4 pa rin ang gagamitin natin divided by half of the horizontal length. which is 2. Okay, next is lahat yan, yung stair slab, negative 4.8, which happens to be similar to the dead loads. So, let me show you. So, mag-split lang ako dito. View, split. Tapos, punta tayo sa dead load ng stairs. Yan. So, stair loads at first floor, yung negative 15.86 stair slab up at 1F. Ito yon. Palitan mo lang yan ng negative 4.8. Next. Ito naman, stair slab up and down at 2F. Ito yon. So, 4.8 din. Tapos sa third floor, ayan. Stair loads at third floor, also negative 15.86. Ito yon. This is going down at third floor. So in short, pwedeng nating i-copy to from the editor. So punta tayo ngayon sa editor. Utilities, command file. Nandito siya sa reference load, ano? Click natin si stair load. Ayan. Select everything here. And then, hanggang dyan lang. Copy na siya. Tapos, i-paste mo dito kay live load. Ayan. Okay? Sa ilalim yan, doon mo siya ipe-paste. So, stair loads, tanggalin lang natin itong railing. Okay? Next, tanggalin ulit yung railing sa second floor. Tanggalin pa rin yan. And then, member load sila lahat. Okay, so this is member load. Wag mong kakalimutan yan. Otherwise, malilito si STAAD kung ano yung mga numbers na yan. Okay? Next is, so ito na yung mga stair slab. Papalitan na natin ito ng negative 4.8. Okay? And then, this is simply your floor loads. So, we now click apply or save, then exit. Next. So, I will remove the split again. Let's look here at the roof loads. In some cases, or in most of my designs, yung trusses tsaka purlins, dinedesign natin siya ng may live load. That is simply because yung purlins mo, binubuhat niya yung mga nagtratrabaho doon. Yun yung live load. Ganon din sa trusses mo. Binubuhat din niya yung mga tao na nagtratrabaho sa purlins. Okay, so ibig sabihin, your purlins is safe against live load. Truss is also safe against live loads. Next is, ipapatong mo ngayon yung truss tsaka yung purlins dito sa structure mo. Ngayon, kapag naipatong mo na yung truss dyan, meron pa bang titirang tao sa yero mo? Siyempre wala na. So at this point, pwede mo nang tanggalin yung mga truss loads na yan. Or yung mga truss reactions na live load. Okay? Anyway, sorry. Ito pala yun. So, stair load, roof loads, ito siya. So, roof loads, interior truss reactions, negative 7.138, negative 6.484, and then, meron siyang exterior truss reactions. Okay, so, magde-decide ako ngayon na hindi ko na ilalagay itong roof live loads. Okay, so not included in loads. Okay, yan. Anyway, saan galing tong negative 7.13? Kinuha ko yan sa design ng truss. Anyway, we will not include this anymore. Next, at editor, just before finish, you type perform analysis and load list all as shown below. So, balik tayo sa editor dito. Just before finish, then you type perform analysis and then load list all. Then save. Ngayon, ayusin natin. Take note na sa dulo ng end defined reference loads, nandun si floor diaphragm. Tapos after floor diaphragm is check soft story, which happens to be this part, ano? So at editor, type check soft story as a 7 after last line of floor diaphragm. And remember that si floor diaphragm, ginawa natin siya after ng paglagay ng EX values, itong 0.05 tsaka yung 1. Okay? Tapos dapat magkakasunod yung ating load cases. Load 1 seismic, load 2 seismic, load 3 dead, load 4 live, and then perform analysis. Now let us save, then exit. Tapos we now click run analysis. Then let's see what happened. Ito pala yung run analysis. So, 0 errors, 1 warnings, and 8 nodes. So, tingnan natin kung ano yan. So, check natin yung error, 0, 1 warning. Nasaan yun? Ayun. If this UBC analysis suspension compression, okay lang yan. Tapos yung 8 messages, ayan, neither mass, okay lang yan. Mass model formed, okay lang yan. Weight table, okay lang yan. Then about floor group, okay lang yan. And then no soft stories detected, okay lang yan. Seismic mass, okay lang yan. So yan yung mga messages na okay. Yan din yung warning na okay. Now let's click this floor diaphragm. Okay, so dito sa floor diaphragm, makikita mo yung center of mass. Ayan, at distance 6.71 meters. X direction, ano? And then distance of 4.01 Z direction. Yan yung center of mass at your first floor level. And then at second floor level, yan yung iyong center of mass. Ganon din sa third floor level. Okay, so meron tayong 1, 2, 3. Punta tayo ngayon dito. Sa geometry. So this is first floor, second floor, third floor. Remember na nag-apply tayo ng rigid diaphragm dyan. Okay? So meron din siyang center of mass ng rigid diaphragm. Okay? Yan. Next, let's now go to soft story check. Double click this. So, ang ibig sabihin ng soft story check, safe siya. Ibig sabihin, malakas yung first floor columns mo. Okay, so first story, okay. Second story, okay. Third story, okay. So, yan ang kailangan natin. Ibig sabihin, dito pa lang, nag-check na tayo ng serviceability check. Tsaka strength check. Part of the strength check is that. Aside from that, part of the serviceability check yung drift requirements. Ibig sabihin, dapat hindi sasayaw ng malakas yung building mo. And then look here, X direction, meron kang UBC type 97, ang factor niya ay 0.1294. Tapos meron kang weight 533.56. So ito yung base shear mo, 533.56. Yan o, V. Ganon din dito sa Z direction, meron kang base shear na V. Parehas dapat yan. Tapos yung pag-check ng soft story based from ASCII 7, yan yung tinatawag na vertical structural irregularities check. Okay? Next, let us check the base shear. So, katatapos lang natin mag-analyze and then dito na tayo sa view output file. Okay? So, yung view output file, dito mo yan makikita sa utilities. Ayan, analysis output. Yan, yun. And then, check for vertical irregularities. Yan yung soft story. Ayan, vertical irregularities. There should be no soft story. So, no soft story, then, okay yan. Kung sakaling nang merong fail dito na soft story, then that's the time na palalakihin mo yung mga columns or maglagay ka ng extra columns, things like those. And then meron din siyang mga warnings. Ayan. Ito yung an example of this is if this UBC, okay lang yan. Yan yung sinabi natin kanina. Next, we will now compare results with manual calculation. So, kukunin natin yung value ng seismic mass tsaka base shear. So, ito yon. Ayan. Yung seismic mass, that is ito, 4123.00. Okay? So, tinype ko lang siya dito. Tapos yung base year, 533.56. Ito yan. I-compare natin siya sa ating post-processing. So, ibig sabihin, yung kinompute ni STAAD na dead load. So, punta tayo sa post-processing. Ayan. And then, just click OK. Punta tayo sa reactions dito. And then, punta tayo dito sa load case number 3. Dito, okay? Statics check results. Under this. Click mo yung load case number 3. Tapos, under FY, yan, makikita mo. Negative 4122.998. Okay, ano yung load case number 3? Remember that 1 is EX, 2 is EZ, and then 3 is DL. Tapos, syempre, ang reactions mo is FY, vertical. So, yan, yun. 4122.998. So, sulat mo dito 4122.998, which is basically the same as your seismic mass. Okay? So, i-round up natin yan na 4123.0. So, pasado na siya ngayon.